Right, welcome to the second episode of the Numeral podcast. I'm Al, founder and technical lead, and I'm joined by Phil, Numeral's engineering director.
Hey, I'm Phil. I'm Numeral's engineering director.
Yeah, cool. So today, how we build our projects, why we make some of the decisions that we do, why we have our stack set up in a way that we do, what the pros and cons and the benefits of doing that is. What is front-end architecture? Phil, what are your thoughts on that? How do you define that?
That's a good question, Al. Yeah, what is front-end architecture? I think it's something that sometimes is boiled down to too simply, but I think it can be much more complex or broader than people give it credit for. I think when I think about front-end architecture, I'm thinking about kind of those processes and systems that all go together, but that's not just thinking about kind of obviously, on the face of it, you've got things like your build tool chain. So you've got things like Next.js. You may be using Angular, you may be using TypeScript, all of those different choices for your kind of stack and how they fit together. But I think also it's the processes between how they fit together as well. We've got things like Storybook that we use quite often across a lot of projects, and how we can fit that in to be able to use not only by developers, but also by QA, product owners, or even designers as well, and how that all fits. There's also the side of a kind of architecture between the design system itself. So, not just the code base and the stack, but actually what components are we building? How are they going together? What kind of utilities are we using? What kind of CSS strategy are we using? There's a lot of different kind of facets that need to be explored and just thought about just to optimize that into the best way possible.
Yeah, it's an interesting one, hey, because I think ultimately, like anything that we're trying to do with the front end is to serve the business needs, but put those into the lens of what the user wants to do. And there are a lot of pieces behind the scenes that will go into a good user experience, which will ultimately lead to a good business outcome. But it's all these sort of invisible things like the performance, the connection between the front end and the back end, all of these decisions that are made around what might make sense for the structure of the data or the flow of the whole functionality of the piece of software. But does that then have workarounds that the user has to do in a certain sense? And how can we architect the front end so that the user is having the most seamless and intuitive experience possible without necessarily giving a whole bunch of overload or overhead to the larger application and creating maintainability issues or performance issues? Because there's a well-established research into the fact that the longer that your website takes to load or that it takes to respond to when a user performs an action, it tanks the conversion rate of a website or the efficacy that the website is giving to the user. So when we're talking about front-end architecture, that makes me think about all of those systems level decisions that basically contribute to the success of the software.
Totally, yeah. All about those optimizations, and I suppose what are you optimizing for is always a good question. Different kind of different projects need different optimizations. I think that's where you do get that toss up between there can be like functionality and how quick, let's say, that functionality is, but then you could need security and how secure it is if we're using kind of PII and things like that. So it's definitely a different set of pros and cons depending how you architect something. And yeah, definitely picking those kind of which pros and cons you're going to go with. At the end of the day, there's kind of very few points where there's a right answer or a kind of silver bullet to a solution. If one of those did exist, then everybody would use it. Whereas, there isn't one particular tech stack that everybody uses. There's a lot of different things, which just shows that, yeah, there's a lot of ways to skin a cat.
That's right. And it comes out to trade-offs, say, like you just touched on there, is we have to know very clearly what is the objective of the project? What are we trying to get out of it? What are the constraints we've got in terms of timeline, budget, team size, and team skills? What's the best way to, with all of those ingredients, to make sure that we're delivering a good outcome based on the objectives and the brief, which can be a challenge because it's never a perfect world. You never get the right ingredients for all of those things, but it's always just picking off what's the best outcome that we can get for this. And also, once the project has been built, the maintainability and how much technical debt has been built into it because we're trying to just move fast and break things and get something out there quickly versus spending a lot of time to iterate internally and get something working perfect. And so that trade-off of just trying to get something to market quickly and validate it and then iterate from there versus how long it can take to actually get something working perfect.
Yeah, totally. Yeah, I think it definitely, architecture, systems architecture comes very much from, architecture when you look at buildings and things like that. And I think it's something that, all architects take on board is, you plan your building, you plan what you're going to do. But there are always points where you actually go to, start digging the ground, lay the foundations, and things can crop up during that time. And I think the same with software. We can have all the insights at the beginning, everything that we want to build. But then, we've just got to be able to know that we have that flexibility. So if something occurs during the build, or we find out different information, we're able to kind of flex around that and make the best of those opportunities, and not kind of struggle with them. So yeah, I think it's there's a lot that goes into architecture, and there's definitely saying there's kind of no right answer. I think there are definitely wrong answers. There's there is definitely bad architecture patterns. Speaking of such a project that I worked on a while ago, someone had built kind of a React application, and they were kind of new to React, which is cool. Maybe they didn't know the kind of the full processes behind it, but their history was kind of more in languages like C# and a few of the older languages, and they'd come along, it just felt like it felt really kind of really at odds, I suppose, between the code bases. Kind of obviously anything built in TypeScript, and especially with React, we tend to use less code so you can understand it better, right? You've got fewer files to do things, so you might abstract out a file where you're fetching from an API. It may store it in state, and another file that gives context to a component, and then there may be a subcomponent in there. So you may have kind of four files in this chain to make that particular feature or function work. Whereas in this particular application, there were a good kind of 7 files just to do some of the simplest things. So there was kind of different kind of points of these files. There were type checking between in different areas. So now and again, types were checked immediately when they came in through the API. In other places, they were in kind of further steps down the line. There was kind of state storage and movement that could have been abstracted out or kind of put into one place. And I think basically it's when you move away from kind of best practices, that's where you're kind of getting into bad architecture. So what you're doing there is kind of working away from the mainstream. Like, sure, it's great to innovate, it's great to be creative in whatever you do. But at the same time, if another engineer comes in and they can't kind of logically see the patterns in your code or what you're trying to do, if everything's in the same place, then cool, that makes sense. There needs to be almost an overarching kind of strategy behind the architecture. You're like, what are you optimizing for? Whereas if you're optimizing for, a different thing in every file or every kind of different stage of the process, then it just becomes very confusing because you're like, well, great, this thing's really fast and really performant, but this part's really secure but slow. And this other part, just doesn't make any sense. And it kind of, I think it throws people off, and it's hard for then developers to jump into that code base. And it is one of those things where, new projects are set up all the time, sure. But once your new project is set up, how long do you want it to exist for? If you want it to exist for kind of up to 5 years, you're going to have people work on that code base who have no idea who built it. They won't be, that person may have left the company, they may be in a different company. You can't ask them those questions on why they made decisions. You've just got to kind of look through the code and come up with it yourself. Which lends its point to, architecture. Like, in theory, the perfect architecture would be architecture that you didn't have to comment or document because it would just all make sense. I don't think we yet live in a world where that can be said to be true. I think there's always going to be, user error or developers who do things slightly differently or see different patterns. So I think that's where definitely having anything that's outside the norm or anything that's slightly more complex, just documenting that and having those documents kind of readily available. And again, making sense. One of the other things, I suppose, think about architecture and maybe comes more to kind of the style guides and things like that, and pattern libraries are the ideas between things like as a UI component, you've got cards and you've got
Yeah,
tiles.
preview.
So yeah, you've got two UI components, which when you look at many design systems, when you look at many websites, are completely interchangeable. But the language used there is two different things. It's one of those things about kind of self-documenting things, and file names and component names and things like that. If you've got a tile component and you've got a card component, to a designer, they could be the same thing. To a developer, they could be the same thing. So when they look at them, they're thinking, well, which component is this? I can see from the UI, or I can see from, Figma or whichever design system you're using, cool, this looks like a card, and in my head it's a card, but it may be called a tile in the system. So yeah, I think it's just making sure that when we do look at or between kind of design systems and development systems, or just the project as a whole, we use common terminology. So I think that's another side to kind of architecting things and files and component names, is just making sure everyone's on the same page, that when you say a word in the context of that wider project team, people aren't thinking of different things. They're all thinking about the same thing. So yeah, that's another part, as opposed to making good architecture versus bad architecture. How about you, Al? Have you got any examples of particularly bad architecture?
Well, one thing I was just thinking about when you were talking there is how far things have moved in the time that I've been working as a front end developer, and that there are a lot of now established patterns, libraries, frameworks that almost help with with the front end architecture, in the sense that we use a library called React.js, that has a lot of opinionated ideas on the larger architecture and how the front end should fit in. React only handles the front end. So you need to have a back end that React can ingest the data and only deal with the display side of it. And it's kind of cool to think about how there are a lot of things that we use, and we will use them on every project. And that means that we are all very well accustomed to that way of thinking about breaking out projects. And it doesn't solve everything, because you've still got to architect what the actual front end is like, but it really does help in that separation of concerns things. If you compare that to some other types of frameworks that kind of tie in the front end and the back end into one system, which can have benefits, but one of the downsides is that you are really, if it's tightly coupled like that, your architecture is so dependent, and you don't have as many options to change. Whereas when we build a front end in React, in theory, you can just swap out the back end. You could replace it with something else. And maybe there's small adjustments you need to make to deal with the different API structure. But yeah, there are some things like that. Hey, we're like, in the sense that we always use that on every project, most projects, then there are a lot of efficiencies that we can build in. And every time that we come up with a new problem and we figure out how to solve that, then that feeds into the next project that we do, and the projects become stronger and more robust as we go through time, because we're always feeding those things into our sort of core framework that we use.
Yeah, totally. I think you've, definitely hit on kind of, I think, two really good points there, which is the one that building things in almost a kind of componentized way, or building them separately where you can pull them apart and put them back together, means that you can think about them much easier if they're smaller bite-sized chunks rather than that big kind of glob. And then with those things as well, if you want to update them, we can update part of a project rather than having to think we have to update the entire kind of big part of it. And yeah, to the other point, it's kind of like, it's what we use, it's our bread and butter, it's stuff we use every day, it's the thing that we kind of refine and we hone our craft in. And it's much better to be the experts in that particular kind of stack and what we can do with that stack, rather than kind of jack of all trades, where you're kind of like, cool, I know all of these different things to a semi decent level, but there's still pitfalls, that's still going to take me longer to do these things. Whereas if we can keep on refining not only the kind of processes and strategies we use within our architecture, but also our own kind of skill sets as developers, then we can really grow into that space and just really have things quick, efficient, and built right first time kind of thing. So knowing where those kind of pitfalls are and being experts is definitely something I think Numeral's keen to kind of be a part of.
Yeah, that's right. But to answer your question about the like good and bad architecture, I think like the one that just gets projects unstuck is when over time a project moves in a certain direction that the developers and the architects weren't aware of when the original version of the application was built. At any point when there's new features to add in, there's always the decision: do we tack this on top, look at what has been done up until this point, and refactor where required? And often that can just be such a huge undertaking that the decision is usually made to tack it on top. And also, if you are going to set the project up to be able to cope with things like that, you have to build in such an amount of extendability that you are just could be adding a lot of budget to the front of a project. And who knows, maybe the project gets scrapped in 18 months. And then, so I think that is usually where I've seen architecture kind of falling down, and it's no one's fault necessarily. I've been lucky enough, I haven't really seen examples of architecture that I would say, like, oh, that person just didn't know what they were doing. They did a bad job. They could have clearly gone a different way. It's normally more that everyone's doing their best effort with the information they've got available, and then things change. And so that then what happens is, I mean, I've seen so many projects where it's just Frankenstein. You can tell that this was done. The original project was built 4 years ago, and then 2 years later, they tacked this thing on. And then now we need to do something that has to deal with the original app and this thing. And then you just don't know how to do it because neither of those things were architected in a way to deal with what you're trying to do now. And I think that's the big challenge of architecture is, to draw back to what you were saying before about like building architecture. Usually when you build a building, it's just, and that's it, and then it stands the test of time. And if you need to go in and do a renovation or whatever, then you just rip a few walls out and you do the whole thing. But with architecture, it's so much more intertwined. Like it's often...
there's not many houses where you build a building, let's say a house, and then you build the equivalent of a house kind of next to it, and then you build a bridge between the two, and then you build a wall around it or something like that. That's the software equivalent, which happens on probably a daily basis, knowing most software projects. But yeah, in terms of coming back to kind of building architecture, things just aren't built that way, right? Yeah, yes, you'll stick a conservatory and an extension on your house, but generally that's a smaller part onto the bigger thing. Whereas, yeah, as you say, with these systems that grow, the first application or the MVP or the kind of first version is quite small, and then they grow bigger and bigger and bigger, and it's thinking about that architecture kind of as it grows, which again, why I'm a massive advocate for kind of that reusability and that componentization, is just to make those things so that we can think about them in more abstract ways and separate ways, so that we're not trying to think of the full context, but also when we do think about those things, we can adjust them or swap them out or upgrade them much more easily in kind of bite-sized chunks than trying to do the whole thing in one go.
So one interesting thing to think about is why should product owners or why should people who are commissioning a project, why should they care about architecture? They're not necessarily technically minded. That can sometimes be a challenge. How do we kind of communicate some of the pitfalls or the challenges around architecture? What are your thoughts on that?
Yeah, it's definitely an interesting one. I think it's, again, with all of these things, it's a kind of education piece for any stakeholders or anybody who's kind of in charge of making those decisions, or where they put the effort and the time. And kind of there's an element of measure twice, cut once, although with the kind of vibe coding around at the moment, it seems to be cut 14 times and then maybe measure it, who knows, and then throw it out there. But I think definitely when planning things, anything that's big, anything that's complex as a system, which is what we generally work on, you want to be planning it, you want to be measuring it, you want to be doing all of that work up front as much as you can, as much as possible, before you start actually building anything. So you know what you're building already. Same as building a building, But yeah, I think just that education piece around, what is the cost of the project, right? Because you're thinking, let's say between those two options, you're thinking, cool, we can build this and it will be integrated into the current system, or we can tack it on top, as you said. And it's kind of like, cool, well, the cost to tack it on top is, let's say, X amount of dollars. The cost to build it properly and integrate it with the system might be 3X the term of dollars. But then you're looking at that future prices, like what else are you actually spending there? So that tech debt may be actually worth 5X the amount of dollars on top. You know, and yeah, so you're borrowing from the future in that sense. So it's very much just trying to work out, you know, where what is the best case for these particular things, because as you say, it might be that the project finishes in 12 months or something like that, you know, or they decommission it. So spending that extra cash to kind of build it properly, you know, actually wasn't worthwhile in that situation. You could have just tacked it on top because the thing was going to be decommissioned anyway.
And this is the thing, like it always has to be a pragmatic decision around what is the best use of effort and time and budget versus what you're going to get out of it. And sometimes the best decision is to intentionally build some subpar architecture, because it's just, at the end of the day, it's about getting the business outcomes and that the users can do what they want to do. And as long as the software is still strong and robust and scalable, and maybe not necessarily scalable, but that it performs well and that it's secure, like you always just have to put everything in a list of priorities, hey, and you just have to be pragmatic about what you're doing.
And that's a thing, right? You can inform and you can show, and that's, you know, one of those things that half the time being a developer isn't coding, it's explaining to people who aren't developers kind of what their decisions actually mean, like what is the full outcome of those decisions. So to help them understand and to help them make the best decision in those kind of times. Yeah, definitely. One of those things as well is kind of like looking at that holistic view of what do you actually get out of that. So something that we try and do a lot in our projects, obviously, is to try and kind of actually have a little bit of kind of cross-project collaboration. So yeah, sure, we might be tacking something on in one project because that's going to be decommissioned soon, but maybe the learnings from that can be taken to a project where it can be kind of built in the better way, the more kind of fundamental way. And then again, if we're building that on a particular project, then we can take those learnings and we actually say, you know what, it's not going to be a choice between X and 3X, it's a choice between, you know, X and 2X. So much easier to kind of integrate that because of the learnings, again, because we're using similar stack and because we're getting experts in this particular field. You know, we can do it quickly, we can do it efficiently, and we can take those learnings between projects into the kind of the whole kind of side of things.
For the most part, our stack is React.js, Next.js, Tailwind. What else am I missing?
We've got Sandy. Sandy is the main CMS.
Sanity is a headless CMS. Yeah, that's kind of
that's the main, yeah. Superbase is kind of a database side of things. We've got Storybook for kind of the integrations with kind of a design or pattern library. Yeah, I would say that's kind of our core, or Cypress as well, because we may as well throw in end-to-end testing. You know, this is the thing, right? Is, you know, as you get expert on kind of the particular stack you're using, you know, we can do more and more things, and it becomes more and more efficient and cheaper and cheaper and cheaper. So it's like, actually, rather than just getting, you know, your website, it's like, here's your website, but also here's a pattern library, here's a end-to-end testing kind of system built on, because we're quick and efficient at doing it, we may as well do those things from the get-go. And again, that's where kind of speaking about architecture, you know, it's kind of like, what are the added extras that give a massive kind of return on investment in terms of being scalable or being kind of maintainable longer term. And yeah, where we can do that, again, that's where we can kind of collaborate between projects to make that easier and better across the board.
Yeah. With the stack side of things, I mean, obviously HTML and CSS is in there too.
Yeah.
But it's just funny to me that when I started working a million years ago as a front-end developer, that's all I knew was HTML and CSS. And like, you could have a job doing that, but
Wouldn't
now
even need JavaScript.
What's
Wouldn't
that?
even need JavaScript.
No, you didn't. You could totally just only know those technologies. But these days, to be a front-end developer, pretty rare that you could be a front-end developer without knowing JavaScript. And then, as you know, as you start to learn JavaScript and you get more familiar with it, and then you start becoming a full-stack developer, and now you start getting into the database side and the back end and all of those types of things. So it's an interesting time to be a developer or a front-end developer, in that like the breadth of knowledge you need to know is so much deeper than it used to be. And also concurrent to that, the capabilities of the browser is so much more than it used to. There's so many more browser APIs, and the spec for all of these things grow over time as well. Like CSS is
Yeah.
so much. There's so much more you can do with CSS that you used to have to do with JavaScript, and now there's just some clever CSS lines for it. So I think I'm probably going off topic a little bit, but
No,
in
no,
terms,
no. It's a good thing to talk about though, because I think it comes back to that point of like as well with like the speed of loading things, right? You used to use HTML and CSS, and websites took as long as they load like these days, kind of thing. Probably they load quicker now. But yeah, but you've got such a bigger size of kind of site being downloaded, these days compared to kind of in the past. And again, it's just so much more, which means there's a lot more work behind them. They're a lot more than they used to be. So I think that's definitely part of it, which kind of speaks to kind of like, yeah, the reasons why we have all of the kind of extra things. We mentioned what 6 or 7 things in our tech stack from the start. Whereas, yeah, like your old tech stack was just HTML and CSS, 2 things that everybody used. Whereas now it's just growing and growing and growing. But yeah, that's where, again, the hardware's got better. So we've got faster connections. We can do more with that. Your computer's got faster. We can do more with that. And so, yeah, it's just making sure we make the most of that as well with how we do things, how we kind of build things as well to optimize for those. Again, like with our particular stack, it's very much built around that flexibility. There is no such thing as a silver bullet. There's definitely pros and cons to it. But at the same time, we can hit pretty much any website you want to build, any web app you want to build, we can build. We've got the kind of dev tools and everything are really good. They're kind of cutting edge, which means we can build as quickly as we can. It means our developers are happy and they're excited by projects. They don't get kind of stuck in the mud with using kind of older legacy kind of technology. And also, yeah, like it performs really well. So it's performant, it's good for SEO, it's secure, it does all of those things. But yeah, just keeping the kind of newer technology obviously is a really good place to be at the moment. That's obviously things like React and Next.js, and using a bit of a mix of Tailwind and BEM for the kind of styling side of things, just to keep some flexibility there. But otherwise, yeah, as time goes on, what's going to replace React? We've got TypeScript. What's going to replace TypeScript? And always kind of having one foot in the future just to see what's coming around the bend. Yeah, CMS. Yeah. Headless has definitely gained popularity kind of recently. And I think that comes from the fact that, again, it's using different components. So you're decoupling the back end from the front end. So you can just, you can switch out the back end if you need to, or you can develop them independently. So you get slightly more kind of quicker and efficient development. There are pros and cons to it. So in theory, if you're not using headless, if you're using something that's quite tightly coupled, like there's WordPress and there's Django and those kind of code bases, then yeah, you're going to have something that potentially is easier to be performant. It might be cheaper to run all in all on your hosting costs because you're kind of building that static site, but you're going to be losing costs in terms of like the actual kind of dev functionality and things like that. So yeah, they're less flexible, I would say, without putting in more time. Our current stack is very easily flexible. It's cheaply flexible in that sense. So again, going back to some of the earlier points where a project may change or they want to add on something different, we're more easily able to do that. Whereas if we're kind of fixed in the particular system we're using, it's much harder to kind of be able to flex in the ways that the product might need to. So yeah, headless is always a good one for that because again, we're decoupling things. The more we can kind of break things down into bite-sized chunks, the better. Yeah, so we work with quite a few startups, don't we, Al? We've got quite a few kind of greenfield projects. So we've got asked questions from startup founders all the time. And kind of there's an element of technical kind of mentoring, I suppose, and just being their kind of technical partner as well. And there's plenty of projects that we work on where we do get to kind of decide on what tech we're using. And we do get to kind of guide people into using the best choices there. I think the main thing is it's an element of not telling people what they should use or how they should do things, but just giving the information, educating them kind of on what and how we do things, how the kind of modern technical landscape looks, and how they can best kind of work within it. So yeah, what ways can we kind of avoid any pitfalls, but also kind of make the most of what we've got already? Misunderstandings, unrealistic expectations. Yeah, I suppose it is just educating people around, again, where we said there's no kind of silver bullet or there's no right way to do something. It's that list of pros and cons, right? Because there may be an optimal kind of thing we can do to build something for somebody, but that at the same time that might become a really high kind of price point. And so that's where, is that return on investment kind of worthwhile? Is there kind of a cheaper option that we can go for which will do 90% of the work? And just knowing kind of where those trade-offs are, and I suppose that kind of scope as well of the project. Yeah, sure, we can build it, but maybe do we want to build all of these features but do them at 70%, or do we want to actually pick 5 or 6 of these features and do them to 100%? And then yeah, as the product is kind of taken up and grows, then we can obviously add on more things in the future.
Yeah, I think that's right. And I think what it also comes down to is actually dedicating a lot of time at the start of the project, discovery phase with the tech team, UX and UI team, and the client and all the stakeholders to really get a very clear sense of what are the objectives, and rank them. What are the goals that we're all trying to get out of it with this end result? And be very, very clear and very strict around this thing is more important than this thing, it's more important than that, so that we can take that through the next phases, the whole phases of the project, to be very clear that we are trying to achieve these 3 goals. Like maybe we defined 7 goals, but we're sort of saying, let's just pick 3 that we're going to do for MVP and be quite ruthless. If we do have a fixed timeline and a fixed budget, then we do have to be very strict that everything we're doing is heading in that single-minded goal to achieve those specific objectives. Because it's really easy to get sort of distracted, or maybe we'll build this little thing because it's kind of a nice to have, but we have to be really, really clear as a team about our confidence in everything that we're doing, that it is going to head in that right direction. And when it comes to architecture, if we're building an MVP, a minimal viable product, what happens after that point? Is there then going to be more funding that gets unlocked, and therefore we can effectively scrap the MVP and start from scratch and build a whole bigger feature set? And the reason that is relevant is because there are 2 ways of doing it. Either you build the MVP and then you build on top of it, which means that there is a lot at stake. The architectural decisions are very important. And it does also mean that the development time of the MVP will be a little bit longer because you are trying to build it up for robustness. But if the MVP, if its main objective is just to get to market, get some feedback, get it in front of users, and then unlock some funding, and then build the full thing. It's 2 very different ways of going about it. And that decision has to be made as a team. What makes sense for the business? What makes sense for the resources that are available? Because it can be quite hard sometimes to scale something that was just built quickly and just to get to that sort of next hurdle. And then you're trying to scale it and it just wasn't built for that. And it can be a little bit awkward. And that's when you start getting into blue tack and duct tape behind the scenes. And that can be a bit unfortunate. But I think it's like you say, like you're saying, it's the education, it's guiding. If people haven't gone through a technical development process before, there is a lot that needs to be sort of explained about. There's so many things that you wouldn't know would have knock-on effects from decisions that seem quite minor. I think that's the big one.
Yeah, definitely.
And also, I guess, just how complicated the systems that we use every day and take for granted, like YouTube, Facebook, like name any of those big web applications. They're huge, and we are all totally accustomed to that beautiful experience with a lot of functionality behind the hood. And so what that means too is that things that might seem quite simple or quite like an easy assumption that like you would just expect these other features to come along with something, that can be something that can be a little bit of just a process of sort of saying like, okay, if you're using this like multi-million-dollar website as your example case of what you want to be similar to, but your budget is considerably less than that, there does have to be compromises somewhere. And where do we make those compromises? And deciding that as a team, I think, is the best way to go about it. But it can be hard if people don't necessarily know what those things are. And that's something that we really spend a lot of time and effort on, is to, yeah, like you're saying there, like we don't want to tell people what decisions to make, but we want to make sure that people have got the right information to be able to make an informed decision.
Yeah. Yeah, totally. And I think, yeah, that's where that point of, making those decisions as a team comes in, where, definitely any advice I'd give to kind of, either a founder or anyone working with like an agency is not necessarily to tell them your idea of what you want. You can say like, yes, I want this particular feature. Let's say, it's a table or something like that. I want that in the website. I want it to be able to do these things, kind of thing. But also explain to them the reasons you want it. Kind of, I need it. We want this because we think users will find it, good for these particular reasons, and also just putting in kind of like what exists already that we can use, because I think that can be overlooked now and again if a client comes to kind of an agency or comes for advice and kind of says, oh, I want this thing. Often they can get kind of a quote back or an estimate, which is like, cool, this is how much it is to build, instead of like that greater understanding around it, which is like, actually you want this thing and it's going to cost you, quite a lot of money to do it the way you want it. But actually there's something really similar that exists potentially already in the code base that's kind of out of the box that we can just use. And if we use that, it's much less to kind of implement it, 10 times less to kind of code it or develop it into the way we need it. And you'll get pretty much all of the outcomes you're after anyway. So yeah, I definitely think kind of leaning on developers or agencies for their advice, definitely kind of go in with more of your questioning, and you're kind of relying on them to be experts to say like, cool, actually we can get you exactly what you want, but we can do it at, a tenth of the price if we do it this way, rather than just like taking your kind of instruction almost like as an order, and to be like, right, we're going to do this the exact way you said it, because that's what you've told us to do, which is how computers work. But and developers are only one step above that. So yeah, you gotta be kind to us, right? You gotta give us some leeway into kind of, if you're asking for something, definitely just say, this is what I really want, but also what ideas do you have? Well, how would you do that kind of thing? And then just see what comes back. Because I think, there's definitely creative ways to do things, or there's kind of low-hanging fruit or other ways that can be kind of a lot cheaper for founders or kind of stakeholders.
Yeah, that's awesome. Cool. Okay, well, that is the end of our dive into front-end architecture this week. If you want to discuss any of these points in depth with myself or Phil, please hit us up on LinkedIn. We love chatting about this.